We all come from a background of high performance organisations, and really when you've lived in that world you get a real kick out of achieving real high objectives. Now that kick comes from our clients succeeding and really achieving things that they didn't think was possible. So since we started the business in 2005, we've grown and we've now got consultants based in various locations across both North and South Island, and we're supporting businesses that are anywhere from 10 employees to over 3,000 employees. We could be in a boardroom one day.
The next day we can be out on a salmon farm.
And a milking shed the next day.
The next day we can be in a lab working with all sorts of people.
The diversity is what makes this job so interesting for us. We are a New Zealand owned and operated company. As we've grown through reputation, we're now operating on 3 continents. That includes China through the Asia Pacific. We've gone as far as the UK and Europe, the Philippines. Having now 10 consultants in the field across New Zealand, we've got real capability to service larger organisations.
So I was up in Nelson yesterday doing some work in a lab. We're just about to head out to the salmon farm in Stewart Island, so pretty much as far south as you can get. Next stop Antarctica, I guess. The rewards come when you see what you're doing make a difference for the people that you're working with. It's awesome, it's amazing, that's why I do it.
Oh yeah, definitely rather work smarter than harder. If there's an easier way to do it, I want to know about it.
Our desire is to help our clients succeed. We don't believe in doing lean tools to people. What we're actually doing is helping organisations use lean strategically to help them achieve real business objectives and to take them closer to their vision.
So for us this all starts with having a clear strategic plan. And if we've got a clear strategic plan, then we can pick the appropriate tools in which we can deploy in order to help them achieve their objectives.
So most organisations have got a high level vision of where they want to be in a number of years. And where we're helping these organisations is actually turn that vision into a strategy that will get them there. Lean tools are just that, they're just tools. The trick is to make them relevant to the people using them. If we do that, we're going to make the jobs easier, not harder. And really that's the trick to sustaining improvement. LMAC work with organisations across a broad spectrum of industries. We've covered a lot in the primary industry, and of course we cover processing in all different shapes and forms. So that might be FMCG, it might be low volume manufacturing, it might be high volume electronics. We're working in the service industry as well. When we achieve levels of efficiencies that we do, when that allows us to bring manufacturing back on shore, then that's really, really rewarding. And we know with the right approach, we can turn around any organisation. We never say it's going to be easy, but we know it can be done. We feel strongly that we're actually making a difference in New Zealand as a team. We're able to prevent some businesses going under. That's something real for us. That for me is what drives me, is success. This is part of the passion. We know that we can revolutionise an industry, not just an organisation.
All right, welcome everybody, and thank you for joining this presentation today. So my name is Adams. I work for a company called LMAC Group, and we work across New Zealand, Australia, the APAC region, and Europe. We're going to talk to you today about a simulation that we've been building for a client in New Zealand. And there's some really interesting functionality that we've developed in partnership with Simio to support this client on their ambitions to develop a factory of the future. The next slide, please, Cara. Thank you. So a brief introduction to LMAC. So we've been around for about 20 years, founded in New Zealand actually, but we work now, as I said, across the world. We're founded with the view that we could support organizations individually lift productivity, but the real purpose for us is supporting organizations roll up to an industry level and eventually a national level. Recognizing that if we can create high productivity in manufacturers, then we can keep really high quality jobs in the regions that we work with, and support communities as they rally around those manufacturers and the employment they provide. So we started out really with Lean and the Toyota way, looking at productivity in terms of process efficiency, operational effectiveness, and culture. And we've expanded that out now, as I'll talk about, to bring in some other elements of high performance manufacturing. And next slide, please. Thank you. So we sort of pride ourselves on being independent. So we don't have commercial relationships with any software vendors in terms of deployment or recommendation into clients. Our job is really to help organizations understand their own strategy, the transformation that they need to go through to achieve that strategy, and then provide independent advice based on what software, what automation, what kind of markets even they should be entering. From our perspective of having deep manufacturing expertise. So all of our people have grown up through manufacturing and they've led manufacturing floors. And now that they're working on our side to support organizations with that transformation to high productivity. Okay, next slide, please. So this is how we work. So we really support organizations in 3 areas. So the first is to define their strategy. In some cases, that might be taking the organization strategy and developing out what that means in terms of operations and technology, in terms of what the operation needs to look like to support the future state organization ambition, what kind of throughput they're going to need, what kind of performance they're going to need, and building out the roadmap that's going to take them on that journey. We then support that through optimization of current state and optimization of process. So this is what you can think of in the more traditional sense of Lean or the Toyota Production System and Six Sigma. We sort of bring in elements of all of those methodologies to make sure that the operation itself is working as efficiently as possible in the current state that it has. And then in parallel to that, building out what does that future state look like when it comes to technology and digitization that's really going to accelerate the business. So that would be things like automation of production lines, design of process flow, but it's also implementation of things like ERP systems, MES systems, and the integration of all of those things. There's quite a good reason that you can see a circle in the middle there, sorry, which is really the integration of all of those things is really what drives performance. Each one of those things on its own is going to lift performance to a certain extent, but it's really when you combine all of those things together that you get transformation, which is really what we're after. Right, next slide, please. So we work in a few sectors. So you can see here, aerospace, FMCG, electronics, pharmaceuticals. There's a whole range of industries that we work in, but really anything that's to do with manufacturing or operations, that's really where our happy place lies. Next slide, please. Here we go. So as I said, we were founded in New Zealand. I'm actually based in New Zealand, but I work across New Zealand and Australia. So that's the region that I run across APAC. But we've got a team in the UK as well that works across Europe. And we've done work across some of Asia as well, really expanding out from that New Zealand region. Okay, next slide. Here's just a few of the clients that we've worked with. Hopefully there's some familiar names in there. We move on. Okay, so just to introduce the project that we'll be demonstrating today, and I've called out this project specifically because I think it's a really good example of how we can use simulation, not just for this specific project, but actually as a repeatable process for a lot of clients, because the goals that this client was looking for are often what we find when we go in and work with organizations, and you'll see that play through in the model. So this organization is based in New Zealand. They specialize in metalwork, so engineering, fabrication, and production of metal products. So they've developed their own product, which is going into market. It's been in pilot form up to now. And this proprietary product essentially takes some metal components that they produce themselves, so that you'll see laser cutting, you'll see folding, you'll see assembly. And it takes all of those components and assembles them into the final product to go out into market. So the organization has done an initial pilot run of this product where they made 600 units. And that was using their existing setup. So their existing machines, their existing people, their existing facility. And that just proved the product in market, which has been very successful. The challenge for them now, though, is how do we get to scale of that production? So the pilot itself, as I said, was very successful. But in order to reach the scale that they need, they're actually going to have to look at a new facility, or at least optimization of their current facility in some way. And that looks like a 45 times increase in production output from that pilot. So we're going from 600 units to about 26,000 units in the same time frame, which, as you can imagine, produces some challenges when it comes to operating in the current state. At the same time, we want to reduce the unit cost of production. So as we scale up, we want to bring down the per unit cost of production, which means we need to increase the scale of production whilst maintaining existing resource or even operating on a leaner resource. We want to keep manufacturing onshore in New Zealand. This is quite important for this particular client. They don't want to offshore this, so they want to make sure that the production itself is efficiently as run as possible to make sure that we can actually keep manufacturing in New Zealand and that it's viable. And finally, the product itself, whilst it's standard in terms of its design, the size and shape can actually vary a little bit. So the factory that they set up, or the line that they set up to produce at scale, needs to have a degree of flexibility in it to look at following the same process, but adjusting for that scale in terms of size and shape up and down. Okay, next slide, please. So in order to do that, there were a few key questions that we needed to answer with the client, and this is really where the simulation comes in. So the first key question was, what's the potential production capacity of the current factory? So if we were to combine all of the machines together in an efficient line, would we be able to meet the scale requirements of that 26,000 units, as I talked about? Secondly to that, if not, then what are the constraints and how do we identify what those constraints are given the current setup? So you'll see some experiments in here that we looked at to see if we could optimize that current setup to try and remove some of those constraints. And that's where, again, the simulation was really powerful in being able to look at those things without having to actually change the facility in any way before we actually started to make some of those decisions. So we've looked at, what are those ways that we can mitigate those constraints, either by putting more people on, running different shift patterns, potentially even automation, and we can play with that in the simulation as well. And then finally, if we have worked out how we can mitigate those constraints, which might be running multiple shifts or 24/7 production, it might be automation, it might be a whole new line, then we can develop the future state in the simulation tool. And more importantly, we can cost that out. So the client has a really strong view of what the ROI is of their future investment. If they need to invest in new machinery, for example, or a new facility, we can make really good decisions on that, data-driven decisions before actually committing to that capital outlay. And these are common challenges that we find. So this is a really good case study that would be replicated across multiple clients, particularly those that are looking to optimize their current state, but probably more importantly for those that are looking at building a future state, either because they've got growth ambition or they need to meet demand in some way, or because they've got a new market or a new product that they actually need to build a whole new line for. So this is why it's such a good case study. Next slide. So this is the approach we took, and it's been fantastic to partner with Simio. So we've been partnering together for about a year on this project, and it's been a really great relationship because we've been able to develop the model to its current state. So before engaging with Simio, we had mapped out the process flow on a design software, which really sort of gave us the process steps, and we'd done all of the data capture around things like machine time and setup time, so that they were good inputs into the model. But we partnered with Simio to build the current state model, which is what you'll see today, and then use that model to create experiments to build out production scenarios using that current state to answer those first two questions of what's our potential in the current setup, and what could we play with to optimize that current setup without major capital investment. So what you're going to see today is those first two steps. The next step from here, and we're working with the client on this at the moment, is to get into step 3, which is really to design that future state factory. So that's looking at the production line itself, but also the 3D rendering of that model so that we can look at not just process flow, but also labor flow, forklift flow, space and material flow, so that we can actually present something to the client and they know what size facility they need, what machine setup they need, and crucially, how the layout would work and how the flow would work. So what you're going to see today is steps 1 and 2, but just note that with step 3 is going to be built on the top of this. So I think with that, I'll hand over to you, Kara.
Amazing. Thank you, Adam. So hello, everyone. Thank you so much for listening in. So I'm Kiara. I'm a solutions engineer with Simio, and I've been working now with Adam for a good part of a year on this model, working through all the various parts of it, the flow of product from the start to finish, and all of the various components, which we'll dive into when we jump into the software. But before we do, giving a little bit of an overview of what the flow looks like and what the model is going to look like. Right here, we can see a brief video of what everything looks like when we modeled it. So we wanted to simulate the entire flow of the product from start to finish and all of its middle areas, including storage areas, the racks, and specifically the behavior of the workers trying to move the product from every station over to their storage area, where then they could be picked up maybe from another worker or another resource, moved along, and then continue down the line to complete all of their operations. And so when we jump into the model and we continue our conversation, we're really going to start by looking at what are we trying to model? What are we currently looking at? What are we trying to simulate in all of these different stages? And then how do we use this in those future states or in those potential scenarios? So just like Adam discussed, we've already been implementing some experiments to start and look at what could we change in the current system without modifying machinery, without modifying layouts, etc. And what are these changes improving or potentially giving us new ideas for how to modify the functioning of this facility in the future. And we'll dive into the model. We'll actually look at the model inside of the Simio software itself and discuss sort of the key components of it, how everything flows, and then focus on a couple areas that were our main goal throughout our modeling endeavor, kind of the more interesting or intricate pieces of the model, specifically understanding the worker requirements and understanding how do we properly allocate our workers to understand where they need to complete tasks and what to prioritize, as well as the behavior of the storage and retrieval from the racks, understanding how is that being timed, who is picking from what, how much is going into each rack, and how much is getting picked from each rack, etc. And so we'll discuss how we've been able to model all of these, both at the beginning and then how all of that potentially changed or improved as we learned more of both the behavior of the facility at the customer side, but also as we started to navigate better the software, understanding what the best options were for higher levels of flexibility, etc. But going back to what Adam was explaining when it comes to the flow, what we really wanted to model is the start to finish of all of these metal pieces. So there's all of these sheets that start in a rack, stored inside of the facility. And then from there, they begin their entire flow, where they'll be going to various machinery where they get cut into their own corresponding number of pieces. So if we have a larger sheet, those might get cut into 5 or 10 or 15 smaller pieces, depending on the product. And then from there, move to their corresponding storage area, depending on what product they are, and then moved over to the different machines to complete their operations, their shaping, their cutting, their welding, etc., to just meet the specifications needed for the final assembly. So all the way at the end, once they've undergone all these different pieces, they get picked and then assembled into the different stations and then stored into the final racks. And that's what we're using to sort of understand at these initial stages how the workflow is behaving, how everything is functioning correctly. If we look at over the course of the same work schedule, are we able to produce more pieces, more than 600, less than 600 of the initial quantity, and how many days would we need to hit that target goal that we've discussed up until now? But with that being said, let's actually look at the model inside of the software and dive into all of the different pieces accordingly. And so here's the model. And so let me go ahead and start the model run. And as you can see, we have all of our different areas, both from the start right here on the left-hand side of the screen, where our product gets picked from the racks, and then moved all the way downstream by workers, where not only are they transporting material, but they might also be required at the machinery to complete specific operations. And so we can go ahead and start seeing, at the front end, these workers completing these specific tasks or bringing material back and forth. Some of them might be bringing it over in batches. Other times they might be bringing them over individually. And then when we go all the way to the back end, once these racks get filled up with material, we'll have to pick them and then go into their final assembly. And so it's a matter of understanding how everything flows, what the storage capabilities are, and then especially when we reach this back end or the downstream of the line, how do we pick the product from the racks? How do we ensure that we're getting all of the required materials and the timing of it especially? And so there were definitely a lot of different components that went into understanding and discussing the overall functioning and overall behavior of specifically, for example, the workers. So as we mentioned, the workers are going to be required not just for transportation purposes, but also for seizing and work. And so what was important at the beginning was understanding, okay, how are we going to model the capabilities of transporting batches versus individual products, and then how do we prioritize potentially the transport requests of some locations versus others. And then from there, understanding, well, how do we even model the racks, and what were the different stages of this overall flow? And so when we first started modeling, the most important part when starting a model is really to break down the pieces into manageable sized sub-projects. Obviously, when we wanted to start out this model, we had to start with what the flow overall looked like, not really focusing too much at the beginning on the worker allocations, but at the beginning starting with maybe just getting the flow and getting ultimately the processes and getting the storage areas correctly modeled, and then from there layer all of the details. So this was a lot of slow progress and a lot of layering of detail, starting with just workers going one by one, and then adding that flexibility of, can you move product in batches? Can we modify their specific behavior? Do we need to add process logic to make their behavior more representative of what actually happens in our facility, etc.? And so again, what we really started focusing on at the first stage was the racks. So as you see throughout the model, there are storage racks across the entire facility between all of the different machines, because at the specific stages, they might just be processed one at a time. So all of the product in the interim must be stored in various racks or other areas before they can actually continue on to the line. And so when this first started out, we began using servers to model those holding areas. But as we got into the model and sort of the behavior, that required a lot of playing around with all of the specific properties of the servers. So, modifying the processing time, adding process logic to just hold everything and then release it from processing, etc. And it became a little bit tricky to figure out how to correctly model that holding. And so we then transitioned to, okay, let's use racks, but how can we interrupt the holding of only specific products at certain times, etc.? And so to do that, we really used the support of some of our Symbits actually to understand, okay, what is the basic process logic that we would want to use to interrupt that holding? So using the interrupt step in process logic to be able to actually release specific products from our racks, but then thinking about, okay, we can use that example, use that Symbit and scale that to our specific needs. So the way that then this is done is through process logic, we've been able to create various loops and other processes that begin at initialization, and then we'll look through data to find all of the racks and then wait for a specific moment during the simulation, whether a worker becomes available, whether a product has completed processing and the machinery becomes available, etc. We'll be able to then find that instance inside of the rack and then interrupt its storage and be able to actually release it. And thanks to these loops, we've been able, and the use of data, so storing the information of all of the different racks, all of the different locations, where everything is connected to, we've been able to create this one single loop that can look through those tables and be able to release the products needed accordingly. So what that looks like, for example, is through tables, we were able to connect these two racks to this one machine. And so whenever we have a product finishing at this machine, we'd be able to notify for these racks that they're able now to release one of those products and to call the worker over to pick that product and then bring it over. And so that was our first big component of this model, that big hurdle that we have to get over, is how do we model the actual rack behavior? That next piece, though, was when we started, we had no workers because, again, we want to layer all of these different pieces together. That's really how we want to get to these larger projects and how we want to get to these larger models, is by adding layer by layer. We start with the foundation and then we add the walls and we finish with the ceiling. And so when we first started, we had no workers. We just had the product flowing through free space or through our paths without any other requirements. But obviously that next part, which is going to be really important for analysis, is understanding, well, what are our workers doing? Are our workers being efficient? Are we able to utilize them for transport as well as for any manual operations required for any of our machinery? So some machinery is automatic, so they don't require workers to be present there, but others do require some manual support and manual adjustments. And so we needed to take all of that into consideration. And the biggest hurdle for this specific model when it came down to modeling the workers themselves is, if I begin the model run again, just to see it specifically in the front, is understanding how do we prioritize correctly the seizing at a machine and the picking from a rack. Because we'll have products that is already calling for the worker to transport it over, but that worker might first need to prioritize other tasks or other transports down the line. Because otherwise what we kept finding was that the worker was getting potentially stuck transporting the same product from the same location back and forth due to its prioritization of specific transport requests and due to the nature of the first come, first serve requests sorting of those requests. So we really needed to understand both on our Simio side how the worker prioritizes and is allocated, but also from the customer side, what is the behavior that they are looking at in their specific facilities? How are they seeing their workers moving around? So let me slow it down a little bit just so we can see this better at the upstream component. And so when we first started talking, especially when trying to add flexibility, the main pieces were twofold. We're understanding how much does the worker transport at any one time from one rack or one machine to another. So we have, for example, down here, some workers transporting batches, and then other workers transporting one piece at a time. This is all dependent on the product size, weight of it, etc. And so the first hurdle was, well, how do we model the batching movement? When they move everything in groups or in larger components, let's say. And at first we began using batching logic, thinking to ourselves, oh, we can, when product arrives, we'll batch it using process logic and then call the worker to bring that batched product over. But that became really tricky because that didn't allow us really much flexibility when creating scenarios or considering possible simulations of, well, what happens if maybe the worker transports smaller batches more frequently or bigger batches less frequently? What happens if we modify those transport quantities all around? Would that improve our times? Would that not make much of an impact, etc.? And so ultimately, what ended up happening was we needed to use process logic again to add some sort of decision making to be able to modify their behavior and say, okay, based on your ride capacity, which is going to be the maximum quantity, when do I want you to go pick the product? Do I want you to pick it when there's 25 pieces available? Do I want you to wait when all 50 are available? Or do I just want you to go pick one at a time? And so you'll see here that all of our workers have different process logic associated to them in order to be able to evaluate all of the different seize and transport requests, and then look at the different options to understand, am I eligible or are my conditions met in order to transport the product? Or do I need to wait and be allocated differently? And through this process logic, not only were we able to then model when to move products in batches and when not, but we were also able to reflect that same idea of evaluating requests and then accepting or rejecting them for balancing the transports and the seizes. So the seizes would occur at the specific stations to complete maybe cutting, shaping, etc. And then the transports to move the product from the rack to the machine or machine to rack. And so we needed to then understand, how do we prioritize these and how do we make sure that the product is able to flow correctly, prioritizing the movement downstream, then the machinery working in the interim, and then being able to bring over the product from the start over to that next machine so that we can keep that flow going. So that was another big component of our model progress, or the project overall, because it required us to really think critically of what is the best solution to not only model the current behavior, but then again, add flexibility to the system. What if we wanted to adjust our batching quantities? What if I want to have them prioritize these orders differently? And maybe I want them to prioritize always these operations at the machines versus the seize requests. I don't want them to go bring anything else until they've completed everything downstream versus bringing stuff from upstream, etc. And so those were really the two main challenges that we had when we were developing this model, was really getting all of the different pieces to then move accordingly. And then especially down here, when they reach the racks and reaching these outputs. So if I put, just to have us look at this a little bit in the far end of the simulation, when we reach those points at the bottom, you'll start to see, okay, how does everything downstream work to be able to move the product? And so we already have pieces that are waiting. We might have others that are waiting to keep on going, etc. And we have workers and other products. So we can see that, for example, we have some that are already present inside of or at our station there to begin those assembly steps. But we can see that we're also waiting now beforehand for product to come from this rack. So we're still waiting for some of those pieces. But once we were able to then model that worker behavior and understand, okay, how are they prioritizing all of these different tasks and how are they moving downstream? Down at the assembly, we were able to then complete all of our operations to then, when we fast forward to the end of the model run, be able to get a sense of ultimately how many products are we assembling and how are we finishing. And so if we continue the simulation, we'll start to see, even if I pause right now, we can start to see already some of the product getting completed. If I just run the simulation, we'll start to see more products getting completed, waiting to be moved in batches, and then ultimately being stored in the finishing area. And in the current state, what we're really using to measure the behavior and outcome of this model is the finished count of products, so that we can say, okay, if the expected number of finished products for the given time frame, say the 24 hours, is 600, what can we do to increase that? Or specifically, that would be the experiment side, but we're also using that to validate it. So are we actually producing the 600 that are expected during the time frame that we've looked at? And then from there, what can we do to improve? And so currently, what we're really using to just gauge the model's behavior and the model's improvement is that finished count. But as we progress, as Adam mentioned, we're going to be looking at other pieces as well, such as finances involved, costs associated, etc. So we can start to see all of that. And in this model, we've already began experimenting with different options. So for example, going back to our workers, we have them working following a specific worker schedule with set hours and breaks, etc. But one of the questions became, well, what happens if we actually implement different schedules? What happens if we modify some of these schedules of our different workers, etc.? And so we can actually, if I go into the properties, we can start to see one of our controls is actually our schedule. Do we want to implement a standard sort of shift of a standard week, or do we want to implement maybe a second shift where we have workers working maybe an AM and a PM shift? And if we start doing that, what are the impacts of this? And so we've already been able to see some improvement when testing these different schedules. And other options are, for example, testing the machinery. We've added flexibility to all of these different pieces of equipment thanks to the use of data, connecting the data or using data, to connect to the specific processing times, capacities. You know, we are currently processing one sheet at a time, but what happens if maybe we add a piece of equipment so that we can do 2 or 3 sheets simultaneously? Will that improve everything? Or are bottlenecks maybe a storage question for all of our racks? Are our racks not at capacity? And if so, do we need to add more storage or just modify how we're picking and choosing from these different locations, etc.? And so it's been really great to be able to not only see the model progress from where we started with all servers to then developing racks to adding that process logic to adding those workers and really seeing those different layers, etc. But it's also been absolutely amazing to then be able to walk Adam and help him with the development of this and have him also continue on with taking these experiments, playing around with the different pieces and start to really visualize, well, this is what's happening and this is what we want to showcase and this is how we want to move forward with our experiments and with this project. And so this is the model that we've been developing. It's been wonderful to help Adam and support throughout this entire progress or this entire project and seeing all this progress, and very excited for next steps. Adam, do you have any closing thoughts that you would like to end on?
No, I just want to reiterate the partnership, really. Like I say, it has been about a year now, and it's so funny to look back at the model now, and on the face of it, it looks quite simple when we just look at it like this, but there's so much logic that sits underneath it that it's been amazing to develop. And I think a lot of the logic that we've been able to develop in here in terms of workers, in terms of racks, in terms of that first server as well, because that first server takes one piece in and produces multiple pieces out. And it alternates between certain material types based on some logic sitting underneath it. So again, it's something that looks relatively simple, but the logic underneath it is actually quite complicated. But it's really given us a foundation to be able to take this to other clients as well, because a lot of these challenges that we're talking about here are very common in manufacturing in terms of things like picking from racks, what to pick when, which workers to allocate to that, how to model material flow. And so it's something that we'll be using quite a lot, I think, using this as a base and the model logic that sits underneath it.
Amazing. Well, thank you very much for listening. And now we'll go ahead and take questions.
Hello.
Hello. Hey, Adam. How are you?
Hey, guys. Good, thanks. How are you?
2 Adams wearing boots. Hopefully the crowd hasn't had enough of me yet. Thank you for the great work. I'm excited to see that we could showcase another collaboration between Simio and one of our customers. So I really enjoyed the presentation, and we'll get into some of the audience questions. First on the screen we have, how clear were the goals and scope as stated by the customer, and how much did you have to coach them through developing scope of work?
Yeah, it's a great question. So the customer themselves were very clear on their end game. But I suppose the coaching part came in stepping through the process. So a lot of the work that we do is looking at what part of a line to automate or how to automate complete lines. But you can only really do that if you know the current state, so that what you're automating and the capacity that you've got. And therefore the ROI on it. So you might automate one part of a line, but actually that wasn't the constraint in the first place. The constraint is somewhere else. So that's a waste of money, essentially. You're essentially automating waste at that point. So I think the coaching really came in how do we step through a logical process to understand what we've got at the moment, and then what could we do without capital investment, as we've shown, and then we know that where we're automating the thing that we really do need to automate because we can't address the capacity constraint anywhere else. So I think that was probably more the coaching rather than the end game. That was very clear. We need to be able to get to the scale production, and we need to do that with the right investment. But how we get there based on process logic and the data that we've got and we've developed through the model, that was probably the coaching point for us.
Very nice. Yeah, I think it's easy to maybe overlook's too strong of a word, but not investigate thoroughly enough the current state when the atmosphere, you feel there's a problem. It's, everyone's sort of anxious to get on to, what can we do? What do we change? But you got to sort of measure it first, find the bottleneck. Yeah.
Yeah, that's right. And often what we find is the constraint moves. So you might look at one cell in a production line and think that that's the constraint at the moment, and it probably is. But the beauty of the end-to-end simulation is that you can say, well, what happens if we solve that constraint? Does the constraint move somewhere else in the line? And therefore, should we actually be looking at this from an end-to-end perspective rather than these individual cells? And I think that's sort of been the beauty of getting this end-to-end flow, and showing what happens if you solve this constraint over here. Does it move somewhere else? And actually, what's the big unlock? And sometimes that means that you end up investing a bit more upfront, but the exponential benefit that you get from solving both of those things at once actually pays for itself multiple times over.
Copy that. Thank you for the insight. And one of your comments, I moved the order of the questions around. So let's see what comes next, because there was a related question. Give it a moment. I called an audible and moved things around. Perfect. Okay, great. Yeah, so to your point, watching the presentation, I was thinking about this too myself. Can you speak about the challenge of defining the true capacity of the factory at a given time? That was something you mentioned, as it's sensitive to product mix, resource availability, or other dynamic factors over time.
Yeah, and look, all those things. But we really define capacity, or overall capacity, as 3 dimensions, right? So you've got labor capacity, machine capacity, and materials capacity. And all 3 of those things have to be factored in to look at overall capacity of either an entire factory or a line on its own. And so again, that's sort of the beauty of being able to model things end to end, is you can factor all 3 of those capacity dimensions in and then use them as variables. So we were able to play with, for example, labor capacity by setting up the experiment of having multiple shift patterns. What does that do to our labor capacity? Material capacity as well. We can model what we've got starting on the racks as the model initiates. What does that do? Do we need to put more racks in to start with, so that by the end of the day or the end of the week, we've still got enough sitting there on the racks? So that's been the beauty of using the simulation end to end, is being able to play about with all 3 of those factors. And obviously, machine capacity looks at machine runtime. And you saw the data table that we've set up there to be able to very easily change machine runtime, setup time, and that changes that machine capacity dimension. So, all 3 of those things are crucial when you think about capacity. It's not just how fast can the machines run. There's a lot of other things that goes into it.
Yeah. One thing I want to add to this conversation as well is, when considering all of these dynamic pieces, it was important also to pick and choose which ones to focus on first, because each one is going to then impact everything else. The capacity of the racks is also going to impact how much is going through the machine. So the machinery capacity, how much can the machine process, will also be impacted by how many workers we have available. So it was really important, as we began modeling to focus on, okay, which of these factors do we want to kind of consider first? And then once we have that sorted, continue on. And so right now, for example, we've really focused on that labor piece, focusing in on those workers, focusing in on the worker schedule. That next piece that we've already started working and looking into as well was the capacity, the machinery, processing time, machinery capacity, et cetera. And one piece that we are now also beginning to look at is that rack capacity, not just how much each rack can store, but then considering those sort of WIP scenarios of how much is currently present in the facility that we then need to continue process, and how do we prioritize downstream versus upstream.
Brilliant. Yeah, it's a testament to a point made by TMX, if I'm remembering yesterday, that if you set out to just optimize when you have a manifold problem and human factors and all the other aspects that do affect your performance, to just define a mathematical optimization is typically impossible. So we simulate the details, and concurrently, we have a slide in our deck that shows the cross section of concurrently looking at your resource capacity, materials, and demand, and then you have a window of feasibility for what you can achieve. So appreciate the comments there. That's great. Next question. How was the communication between the Simio team, the LMAC team, and the customer?
Yeah, so the LMAC team really led the interaction with the customer. We've been working with this customer for quite a long time, so we're very familiar with them and what they do. And so we had that context, and then we worked very closely with Chiara and the team to actually develop up the technical side of the model. I think what was great though is being able to set up the experiments and the dashboards to be able to facilitate conversations with the client. So it became very easy at that point to run workshops that said, what happens if we play with this? Let's tweak this. And we could do that in real time. And that was really where the power came from, because in those working sessions, you're throwing out what if scenarios all over the place, and being able to just quickly change data in the table for machine time, or set up an experiment to look at what happens if we put another shift on, run 24/7. All of those things could be done very, very quickly in the context with the client. So LMAC really led the engagement with the client, and then we were working with Chiara and the team directly on the technical model.
Yep.
Sounds great. Thank you. We'll go to the next question. Whose decision was it to implement simulation, the customers or LMAC? What benefits do you see as a consulting company with using simulation?
Yeah, so we brought the simulation concept to the customer. It was something that they'd been familiar with as a concept, but hadn't used themselves. But I think that the reason that simulation was so powerful in this case was that they were going from that small scale production to the need to get to a very very big scale quite quickly, and there's a lot of investment that's going to be required to get to that point. So what they wanted to know was, how do we shortcut that process, and how do we make sure that the investment decisions we're making are the right ones, because it's going to be the future of the organization. So once we put the idea of simulation to the customer, it was a no-brainer. They were able to very quickly see the value in putting the work in up front to optimize their decisions down the track. And I think this is something that we see a lot. And so, for us as a consulting firm, being able to use simulation to help organizations model what their future could look like. And it might be as simple as, this particular cell and, what happens if we automate. But it actually, it doesn't even have to be related to automation. Sometimes we'll be using this to look at material flow through a facility. So it might not be new equipment at all, but just how do things flow through the facility itself. Because once you start, you appreciate, once you start moving things around in a factory, it becomes very expensive, and you're getting sort of downtime loss, and you have to close the facility to rearrange things. You want to make sure that you do that right first time. So being able to simulate all of this before we go in and actually do that work not only does it sort of optimize things, before going in terms of design, but it reduces that downtime loss through any changes that we're going to make, because we're going to make them once and we're going to do it right.
Perfect. Well, we're excited to hear that you see the benefit and are carrying the torch to your clients as well. So we certainly appreciate the partnership. Next question. All right. I think we have, I think we still have a few more minutes and a handful of questions. So how did you approach modeling final assemblies and their dependence on sub-assemblies?
Yeah. I can take this one, being a little bit more on the technical side. So when it came down to the assemblies, it was big to understand the components that were required for those assemblies. And a lot of those came from previous stations. So it goes back to that question of timing to make sure, are we getting that flow through and not having workers get stuck potentially constantly in the first machine, just transporting in that start, and then are they able to actually move everything down? And the way that then we modeled the assembly steps or the various components was actually using combiners. So we were able, through tables, to specify as well what were the pieces that were needed at each combiner, or the different quantities needed at each combiner per product. Because again, there's a lot of variability when it comes to, okay, what types of sheets are we looking at? What are the requirements of that sheet? And then at the combiner stages, okay, what is the initial phase of the assembly? Once that's been assembled, where does it need to go? And what is the next piece that has to be added on top of it? And from there as well, the question of timing the pickup of the other components so that there weren't pieces just waiting at maybe the rack or the combiner, etc. And so the way that we approached this sort of the assembly themselves was by leveraging the use of data to be able to specify what needs to be used, what needs to be assembled at each phase, and then the combiners specifically so that we could specify, okay, here are the assembly, the sub-assembly components that we need. And then when they reach the actual processing station of the combiner, we could then begin the operation of assembly, whose times and tasks were all, again, defined through data.
Terrific. Yeah, this is a support topic I get excited about, because working on a lot of different projects, I mean, especially think about aerospace, we see this all the time. And I think it can be a little overwhelming if you're getting started with Simio. Think about, how do I link these sub-assemblies to final assemblies? But we know the tricks now to get them going in the right direction.
It's also tricky to understand, what objects do I want to use to model that? Do I want to use a server for those processing assembly sort of idea of tasks, or is it a combiner better, or maybe using something different and create? That's when I start getting into custom objects, things like that. So that's a very important conversation to also have with the user, because those then, each different strategy is a very viable strategy. It's just a matter then of understanding later down the line, how do you want to leverage that to your favor?
Couldn't have said it better. Fully agree. Thank you for that. All right, a couple more questions. Let's see what we got. Did you have to make any assumptions relative to modeling labor, or did the customer provide a clear picture of the staffing requirements?
Yeah, so I suppose the answer is both. We started out with the current state. So how do they currently set up labor across each of the machines and across the line, and what shift pattern are they currently running? So that was the starting point. We were able to baseline capacity and flow from there. And then we worked with the client to say, what are the options essentially? So how could we set people up to run across multiple machines, or start to finish flow? And then what additional shift pattern would work for them? So each organization is obviously different, and some of them have constraints in terms of 24/7 running, and overtime and things like that. So we had to facilitate a conversation there with the client to say, what is possible in your context. So we were able to then define what would a second shift look like to extend those hours, and then model that out as an experiment. So that was really powerful, because once they could see that, they could see, okay, the impact on the output was considerable when you put that additional shift on. Now, obviously, that comes at a cost, so we'll model that out as well. but it's a fluctuating cost as opposed to a capital investment that automation is. So that's really the baseline we wanted to start with, was to see what could we do with the existing equipment, but a changing staff model. And so that conversation was something we had with the client quite early, and then we're able to model through a workshop with the client.
Great. Yeah, I hear it all the time that kind of throwing people at the problem is, often something that leadership has to decide to do when you're really pinched. So being able to look at different shifts and how can we work smarter, I think is great to hear.
Yep.
All right, so we're gonna do one more question and then we will wrap. What other features of Simio were used to report information? How were results presented to the customer?
Adam, do you want to take that one? Do you want me to take it?
Well, maybe both. I can start though. So yeah, we're in a phase at the moment where we're now workshopping the solution, to look to final design. And so that is now taking all of the information that we've got and we've presented today and saying, is this going to hit the mark? Is this going to be able to get us to the scale that we want to? And we'll work through that process. I think we have to be realistic and say that there will be some further automation required or updates of equipment required. So we'll work through that process with them. But the dashboards that show things like machine utilization are really powerful in this, because we're able to show, we can produce this much in a day or in a week, but look at where the machines are starved of material, where they've got downtime. If we could get all of those machines up to the point where there's very little downtime through starvation or through constraints, then we know that we've got the optimal flow and the optimal capacity through the system. So that was really powerful, being able to show those pie charts of downtime versus uptime. Being able to look at the utilization table as well. So we looked at the utilization of not just the machines, but also the workers. And so then you can start to see, this person's sort of waiting around. Could they be doing something else? Could they be moving to a different part of the process and running that while they're waiting for material to come through here? So yeah, this is a lot of the work that we've been doing now, is to say, what can we do in the context of how things are currently set up, to remove some of those constraints or use the resources that we've got as optimally as possible. And then obviously we'll look to the future design from there. So from a concept perspective, that's how we looked at it. Kara, I don't know if you want to add anything to that from a technical perspective.
I think that the use as well, not just of the dashboards, because obviously being able to go through all of our results and having the tables or in the tabular format was helpful for us to see, but then also on your side as well, on being able to see it as a pie chart where we can clearly see the colors to represent downtime, starved, offline, etc. I think it was very helpful for all of us to then also be sure that what we're seeing sort of makes sense, being able to see all of those values. And then I think as well, when discussing even how to set up that flexibility to then represent it in the experiments, and then defining those results in the experiments so that we can clearly compare, as I said in the presentation, for example, the throughput or the number of final completed parts, being able to then see that across those scenarios to clearly see in parallel what happens with a single standard shift that they're working with right now versus that potential hypothetical future dual shift. Having those, I think, were very helpful from our side as well to see those differences and be able to see, okay, clearly this is impacting it, because it'd be pretty confusing if we made some modifications, but everything was the same. All the results were the same. Clearly that requires some sort of debugging, but then being able to go back and report those in an easy to see and easy to understand manner, I think has been very important, both on the LMAC side to have faith that the model is working and have faith that the system is actually working. And then obviously on the customer side to be able to see value in what's being modeled.
Yeah, so
Perfectly stated. I was thinking as you were talking, it's another topic I'm passionate about during development and after development. You start to plot some dashboards and you get a sort of reflection of, is the model doing what I expect? And then telling the story of your result, really where you start to build value. So,
yeah.
Hey, that's a wrap. Adam, thank you so much. Thank you to all our presenters. I hope everyone enjoyed the conference. I know personally I did. So that's Amazing. It for now.
Okay.
Well, thank you so
Thanks,
much.
Adam.